Hello, good afternoon. Hopefully everybody could hear me. If you can hear me, just give me a thumbs up or put something in the chat just before we start going. Hopefully everybody can hear that. Excellent. Perfect. Right. So today we're going to take a run through what I know about running an engineering business. I've been running an engineering business, my own engineering business now for maybe just over 10 years. And we've been doing a lot of it. We do a lot of it across the globe, across the world. You know, we have employees in the UK, in the US, and scattered around. So I'm going to try and share my experience. You know, there's a couple of things I want to say up front as well on the slides as we go through it. You know, first thing off, I want to say is that my first main message is if you just want to run a business because you love doing FPGAs and you love being technical or you love doing hardware, that's probably not going to be enough. Being technically good is excellent, and you'd need to be able to do that, but you're going to need a little bit more than just being technically good. And you're going to have to do a lot of things that you never thought of, because I ended up having to do a lot of things that I never thought of as well. And the other thing is, I really want to say this is that what worked for me might be very different to what works for you, right? So this is what works for me and how I and how we do it and how we worked and how we've been successful. But of course, there's a million and one ways to be successful. There's also a lot of ways to fail, and I've failed in a few ways as well as we go through, and we'll talk about that. If you get any questions, if you think it's just me on here, so if you get any questions, just throw it in the chat, and I'll try and keep an eye on it and answer as we go through. And just pop it in there and we'll be good. First, I'm going to give you a little bit of background about me. I've been doing FPGA design for 25 years, and I've really done a lot of design and development stuff. So pretty much every application you can think of, I've worked on for FPGAs. I've done radar, cryptography, image processing, nuclear reactors, anything where you can anything where you might want to use an FPGA, I've put it in there. And yes, this webinar should be recorded and be live on the YouTube channel later on. And I think you can come back here and watch it also. So I've worked for some large defense companies, some large companies, Raytheon, Leonardo, Airbus, MBDA. And in 2014, I decided I wanted to work for myself. And since then, it's been relatively successful. But there's some things that I want to talk about. And the first thing I want to talk about is my career, a little bit about my career. Because while I say I've been doing FPGA for 25 years, I have, but that's not exactly entirely the truth. So I started out back in 2000 as an engineer for Raytheon. I started developing FPGAs for Raytheon, and then I quickly moved on from Raytheon. Did a few years at Raytheon, did what a lot of engineers do, and I moved from Raytheon to Ultra. And then I went contracting, because one day I looked around the office and realized that I was one of the few people that was a permanent employee, not a contractor. So I thought, well, I want this contracting money too. So I went contracting, and then I went and did some FPGA design on image processing and things like that, which was really good fun. However, that takes up to about 2007. And in that time, obviously, it was very heavily FPGA specific, some board design, but a lot of FPGA stuff. In around 2007, I made a transition and I began to work in the space industry, and I moved away from doing such like day-to-day FPGA work and was more focused on becoming what was called a design authority. Actually, they called it responsible engineer. I thought that was a great term because that meant every other engineer was irresponsible. Obviously, they've met a lot of engineers. So I moved and in that role, I was in charge more of some of the architecting, the schedule, some of the risks, in liaising a lot with customers, with clients, running things in clean rooms, getting things through there. So really looking at not just the FPGA anymore, but the overall side of the system, and being responsible for that. And I think that actually helped me gain quite a lot of experience that's coming later on. After that, I'd always wanted to be the head of engineering somewhere, so I made a transition and became the chief engineer somewhere, and that was kind of like the first time that I, in the engineering side of things, when I was at Airbus, doing the engineering side of things, I was responsible for people, responsible for teams, and yeah, I took a few people through things like capability assessments and things like that if they weren't performing. But when I became the head of engineering in the management side, that was the first time I actually handled a lot of the, a real lot of the HR drama and the HR pain that comes with managing people. Unfortunately, at times, you have to let people go, you have to recruit people, and you get to learn the insanity of what HR does to a business, which is they don't really contribute a huge amount. After that, I should have actually left and formed my own company. But I didn't. I ran on for another 12 months or so, doing some executive management for a large defence company. Then about 2014, like I say, there was a bit of an overlap. I'd formed my own company. It was off and going. In the time when I was doing all this management stuff, I was actually still doing a lot of FPGA work on the side, and at home over evenings and weekends to keep my skills sort of going and telling. The reason why I wanted to say this really is because for me, it's about how to go away and how do you know when to go and form your own business, or how do you know when to go and create your own business? And for me, ideally, I think you need to have several major projects under your belt. I think you need to have gone through several developments, and you need to have seen what works and what doesn't work. When I sit back and look at my career, I think about it. Actually, the projects that worked, I'm exceptionally proud of pretty much everything I've worked on. And I was very proud of the projects that worked successfully. But the projects that didn't work, the projects that we had problems with, that we had struggles with, that were a real challenge, they're the ones that I actually probably learned the most about running my own business for, and how to deal with it. Because when you run your business, the book literally does stop with you. If something doesn't work, you've got to get it working. If something goes wrong, you've got to work out how to do that and how to address people and how to do that challenge of going and talking to people and saying, well, this is not going right. So I think it's important to get several projects from under your belt. Learn, if possible, in different industries as well, so you can learn how different things work, how different companies do things, different structures do things. You're just adding to your skills. And that learning when projects go wrong, that's quite an important point, because I had something a few years ago where we tried a young engineer out. They didn't quite do it right. They were just starting their own company. So I thought, I'll give you some work to help you do it. Unfortunately, what was designed went a bit wrong. And you have to deal with it. You have to phone the customer up and say, we were supposed to deliver this project, but actually there's been a terrible error in the design of the hardware. It doesn't quite work. It's not really salvageable, but we're going to make it right. We're going to work with it right. And we did make it right. We did deliver it to them. We did get it right. And the customer came back and said, I was really appreciative of the way you handled this and the way you handled things when it didn't go right. That ability to just pick up the phone, just talk to somebody and say, look, it's not good when somebody sends you an email on a Friday afternoon saying, excuse me, dude, can we have a chat? And then you have to explain to them, but you have to take that responsibility and say, it's your fault. It's, this is what's happened. This is how we're going to fix it. This is what we're going to do to make it right. So you have to learn from these things and get as much experience as possible. I'm laboring the point a little bit, but I'm sure you all sort of get it. One of the things that begins to think about this afterwards is like, well, how do you get work? Where does kind of work come from? And it's an amazing thing, really, that throughout your career you build up a huge network of people. You build up a huge network of people that you talk to, that you work with, that you become friends. In some cases, you just sort of work friends. In other cases, you become quite close personal friends with them. And that's what it's all about, is that network and that existing contact. For me, one of the best things I did was write the blog. To this day, the blog is still the best sort of business advertising, the best sort of thing we do, because it puts something out there and says, actually, this guy knows how to do stuff. But that's just the truth of building your network and exploiting your and creating your network with your friends and previous employees, because people move about, people stay, you move about. So you want to be able to communicate with people and talk to people and see and see what's going on. And it's amazing. So many of the companies I've left, and I'm like, oh, I don't really want to do any work with that. When I was a permanent employee, they come back and they become major clients of Aduvo over the years, where we still work with them to this day, because you'd built that reputation up and that ability to deliver and to commit. One of the things, I try to build relationships. Hopefully everybody realizes this, but I try to be very open and honest and work with people. So I try to support as much as possible of the freelancers. People starting up, people want advice. I'll work with them, I'll collaborate with them. If we've got work, I'll share work with them, because that collaboration creates opportunity. And I'm a big believer that we all kind of go further when we all sort of collaborate and work together. One thing I don't do is, once we've got the pipeline going, once we've got the team filled, or I'm busy, I don't stop marketing, and we don't stop looking for the business, because it can actually take a huge long time between somebody reaching out to you and saying, oh, we've got this work that we'd like to do, and actually signing a contract or agreeing the terms or working forward with it. So that it becomes quite a challenge. It becomes quite a challenge to do that. And if you and I do this all the time, actually, that I have several projects all out there that you're bidding on and hoping that some will come in soon, some will come in slightly later, and some will, generally you can bet that some of them will come in simultaneously, and then you have the fun of working with it. But you have to try and be always trying to work out what that pipeline is, and keeping that pipeline, because things will come. Things will drop out, things will move out, and it's very important to try and keep that pipeline created, keep that pipeline coming in and going through. So that's a little bit about like my background, where we come from, what we do. So when I started a company, one of the things that I wanted to do was I really sat down and thought about, what is it we want to do? How do we want to do? What do we want to do? And where do we see ourselves going? Do we want to be a small company? Do we want to be a huge company? And I made the decision that I'd rather want to be. I'd like to be a smaller company than a larger company. I'd like to be a small company that does good, exciting, interesting work, and is also a good employer. And we'll talk about that later on. I like to be very fair with people that work for me, either as contractors or as sort of permanent staff. Nick, I'll come to your question in a minute, if that's okay. So we sat down and we defined a mission of what we wanted to do, and a vision of where we kind of wanted to go, and where we thought we got a sort of a right to play. We worked out that we're very good in the FPGA world, we're okay in the embedded system world and board design world, but the RF world, for example, it's probably not for us. So we worked out where we want to go, where we think we've got a natural right to sort of execute and develop our programs and missions. And anybody that follows me, particularly on Twitter, will know that I'm not a huge fan of process and reviews and things like that. I believe you've got to have a sensible process, and it's got to be straightforward and usable, but I'm not a big fan of doing work for work's sake, shall we say. But we do sort of annual reviews, and sort of every couple of months we have a look and say what's worked for us and what's not worked for us. So there's a few things along the line that we've worked out haven't really worked for us. We've had a few contracts over the years with big defense companies, and if I'm brutally honest, and I think they would say the same, they've not hugely worked for us, because they're very rigid in how they work. They want you to not use your IT and your processes, but their IT and some mixture of their processes and your processes, because they're terrified about a law in the UK called IR35. So, in doing reviews, we've realized that actually that's a lot more pain for us than it is. It's a lot more painful for us than it is actually doing and delivering. And we want to try and align when we think about our strategy, we want to try and align what we want to do. So we generally, everything we've done has been bootstrapped. So everything we've done has been sort of invested in my money, and I don't take a lot of money out of the business. In fact, most of the staff probably take out more, get paid more than I do. because I keep most of the money in the business to invest and to grow and to allow us to do things. So we invest in our strategy. So a few years ago, we worked out that actually we'd like to create some development boards and some target boards. So we've invested in doing that because that's an interesting area where we can go and where we can work and where hopefully we can develop and grow. We'll talk about the insanity of creating conferences and journals and such like later on, because that's a more recent thing. Nick, just to answer your question, so I've probably got maybe like 4 or 5 sort of potential projects in the fire at any one point in time. Talking to like sort of 4 or 5 customers at any one point in time as to where we go. It depends obviously, because the company's fairly small. There's only like 5 or 6 of us in the engineering side, and a couple in the event side. So it really depends upon how loaded we are and how busy we are as to what we do. I have got better. I used to say yes to everything, to be honest. I've got better at saying no to people than I have at than I just say yes to I say yes to everything. But it's a very difficult thing when you run your own company, because you always want to be bringing in money, and you always want to be making sure that you can pay your staff, and you can pay the rent for the room, or you can pay the IP core license, the licenses for the tools and such like that. So it becomes a challenge. So this was talking about mission statements. This was our mission statement that we came up with, just to be able to give that, just to be able to set aside and work out actually this is what we want to do, and how we do it. And this, I have no secret. So this was kind of like how we sat down, and this was our first sort of the output from our first sort of strategy review thing, where we worked out what our values were, what our aspirations were, where we thought we could win, where we thought we could lose, what our capabilities were, and what some action plans and things like that to come out of it were. So this was very much basically, me and at the time my chief engineer and a couple of others sat down and working it out. So I'm going to talk about tools in a little while. But yeah, initially everything was done here out of my own pocket. So I've not taken, there's no investors, I've never taken a loan or anything like that. Everything was sort of done out of my own pocket. So it's been a challenge, shall we say, at times, but these days it's been I think it's kind of paid off. And we do quite well. I have some strategies, and some of the things we're going to talk about next. I have some strategies and things like that we use. So I have some basic things that I expect and that we run through. So clear, we probably have. So the staff numbers I gave you as permanent staff, and then we have probably like another 5 or 6, sort of maybe 7 sort of contractors that we use and flex as and when we need them. And those contractors might be FPGA people, or they might be like board design people when we're doing board designs. So we kind of flex and pick to the same thing. So one of the things, like this is where like the technical side of things is a bit is like, being technically good is one thing, but you need to kind of understand the business and the flow of it. And cash flow, honestly, the number one thing I've learned in this is cash flow is really, really key in doing this, particularly when you're first starting out, or when you're first working. So I have a rule now, and actually I learned this when I was I would have eventually learned this. Maybe I'd have gone bankrupt first, but I learned this when I was back as the head of engineering at a place. So I never work cash negative on projects, which means I'm never using the company's reserves to pay the staff and such like on a project. So if we engage with people on a project, and generally we will do a fixed price engagement. So generally we will do a fixed price engagement with payment milestones through it, such that we get paid as we achieve things. We get paid. But I will always want a fairly substantial payment up front. We will always want a fairly large payment up front, between 25 to 50%, depending upon the size of the contract and whether we've done work with that customer or not beforehand. It helps us to be able to have our cash flow going forwards, because we know that we're not investing money and then not getting it. And a few years ago, I did that. I was using my own cash on a project. I should have stopped it. I got a couple of contractors working for me doing some board design, and I got maybe £60,000 worth of invoices into this company, and they went into chapter 11 bankruptcy, which means that you lose your 60,000. You go into the creditors list and you'll get like maybe pennies in the dollar. But I'd still got contractors to pay. Now I could have just walked away from it. Dude, they've gone bust. Sorry, but I actually paid them out of my own pocket, because I believe that that the contract was between me and them, not what happened to the end customer was neither here nor there. So cash flow is really key, because cash flow allows you to build reserves, and allows you to sort of do it. The other thing I will mention is we did a project on an ESA project, a NASA project on Gateway, and that was started as like a 6 month project with some huge liquidated damages if we didn't hit the timescales and margins. Then the customer started moving things and delaying things, and it delayed for years. And those milestones that you think, well, I'm going to get X amount of money before 6 months' time, those milestones suddenly got very interspersed out. So you have to keep an eye on that, and you have to be able to go back and talk to people and say, actually, hang on a minute, because we need to renegotiate these milestones. If you're moving the milestone, then we need to work something out. So rates. So how we set our typical rates is we work out basically what our costs are every year. So we work out how much it costs for the office. The office is fairly cheap. It's about £800-900 a month. Internet, staff salaries, my salary, our tool licenses that we need to buy, travel budgets, all those things like that. And then we work out how many people at one time are going to be working on a money-making project, because not everybody might be working on a money-making project. Sometimes things don't go quite right, so you're waiting for, like I was just saying, you're waiting for a milestone or something comes up, and then we divide that to work out an hourly rate, and then we take it from there. So our hourly rate is relatively cheap. Although I just told it to a recruitment contractor, and a recruitment agent who phoned me up actually, and he nearly fell off his chair when I told him. But I had to then explain that there's a very much a difference between a contractor who goes on site and like a consultant that's got offices, fixed price costs, and things like that. So budgeting, we factor in tools, travel, boards, training, and contingencies. I have a rule with tools that I want to buy perpetual licenses if possible, because I don't want a bad year to mean that we lose that capability or we lose that tool. So wherever possible, I buy perpetual licenses, unless you and then a company like Altium comes along and changes their perpetuality. But that's the other thing. With taxation, obviously you've got to understand, and you'll have an account. You'll need an accountant and a bookkeeper as well. And I do apologize to my accountants and bookkeepers, because I'm sure I drive them up the wall. But you need to understand things like value-added tax, sales tax, and what the profit's going to be. And I'm very simple. So I have two bank accounts. One bank account, the money comes into as the customer pays it, and then the minute the customer pays something, I take the tax amount, the amount that's due on tax, the full value of that, and stick it in the other account. And then at the end of the year, I've got an account with a pot full of money that will pay the taxes, but the accountant's going to have worked out that actually I've had many more expenses that mean the tax comes down, and then there's a little pot of money at the side of it. So let's try to answer some questions. So dual nationality, find it difficult to get working. Did something wrong or just nationality? I don't know about the dual nationality kind of things, actually. I've never. I think most defense companies these days are okay with dual nationalities, particularly because most defense companies these days can't recruit people. It seems very difficult to get people. Able to get upfront cash flow when you start the company. From customer's point of view, see this company as a startup, how could you gain their trust? That's a great question, Mohammed. I think I was quite lucky in that, and luck plays a part in it. But I think I was quite lucky that a lot of people knew me, and I got quite a reputation by that point in time. So that helped. But it took me a little while before I started to work this out, that I should charge cash up front. When I first started doing it, I was very much like, well, we'll do something and hit a milestone, and then you pay me. And it took me a little while to work out that actually I shouldn't do that. Is there a reason to go for contracting service businesses instead of producing your own products or running a product-centric business? Yes, kind of. The honest answer, Nessa, is I kind of fell into doing the contracting services business side of things, and never really thought too much about creating products. That's something that's changing. You know, we have training products, we have board products now that we've developed, like our little Spartan 7 tiles or our Spartan 7 dev boards or our IP cores that we've started to do that. But by and large, the easiest, lowest cost thing to start up was a sort of a consultancy sort of business. So really, like, you know, we want to make sure, I'll not talk about this slide a huge lot, but when we're thinking about the tools that we want to use, you know, I try to, wherever possible, like I say, I try to buy perpetual licenses. And in terms of tools, you know, we use Questa for simulation. We use, you know, we've got full licenses for Vivado, Libro, Lattice, Quartus type things, because you never know what your customers are going to come across and want. MATLAB Simulink, we spend a lot of money on every year for that, because we want the ability to go from HDL to RTL. You're going to need people, you know, an accountant and a bookkeeper is excellent. You know, my bookkeeper is the best person in the world. You know, she helps me. She works out where expenses should go, what the tax looks like, how the business is doing, you know. And insurance, you know, do not forget to think about insurance, because you're going to need professional indemnity insurance, you know, public liability, product liability, employer's liability. You're going to need that sort of that one. So Vivado, I think, is about $4,500 a year. You can find that on the AMD website. One of the other things I want to talk about, yes, of course I can, Adam. So I have a load of insurance because I'm quite paranoid about it. But obviously I have like contents and insurance and all that sort of stuff. But I have professional indemnity, public liability, product liability, and employer's liability. So they're the ones by four. Then I have some other insurances that provide protection as well. Like against the directors of the company should anything go disastrously horribly wrong, although touch wood, it never has. The insurance can be quite expensive because it's based on your turnover, number of staff, and where you do business. Because we do a lot of business with US customers, that turnover becomes quite expensive, shall we say. So we have to think about that. One of the things I wanted to do as a small company as well is we're quite focused on trying to define our engineering process. You know, we don't want an overly onerous process, because at the end of the day, we want to be quick, we want to be efficient, we want to make money, because we only make money when we deliver to a customer. And that's the important thing. But we want a structured process that everybody can follow, everybody can understand, and everybody can work with. So we define our end-to-end engineering process, and as a minimum, you know, we manage sort of planning, hour tracking, change control, you know, document storage, code storage. We tend to be quite cloud-based. You know, we use a lot of Confluence, Jira type things, and we have a lot of standard sort of directory structures and version controls. Open source tools are great. I don't mind using open source tools. Generally, 9 times out of 10, when we're doing stuff for customers, though, they expect more sort of professional tools like Altium or something like that. If we're doing board designs for them, normally Altium is the one everybody wants. Some people want Mentor graphics pads or something like that. Yeah, good luck putting customer names and things like that on your website and in social media, because most companies don't want to admit that they're using external companies and external conferences. There's one in the UK that we've done a huge amount of work for, and we've really enabled their product. It wouldn't exist without us doing what we've done recently, and we can't mention it, we can't talk about it, and it's quite sad when you see it on sort of social media and you just want to put a comment on the bottom of it like, we did that. But you know, it's a team effort and it's a relationship thing. You know, you're not in it for the glory and the pat on the back. We just want to do good engineering and see things like see things like that. I've never got any ISO qualification. I've never got ISO 9001 qualification, but nobody's ever asked me for it neither, to be honest. But sometimes I can be a little bit sort of so these days I'm a little bit more like with customers. I'm a little bit like, this is what it is. Take it or leave it. Particularly with big companies because they tend to like a lot of crazy process. So we codify how our work gets done. Just to show you there, you know, we've got the how-to guidance and coding standards and code generation, systems engineering that we're big fans of. And then we've got, you know, the principles about how we use this, how we create IP, how we use IP. Sometimes customers do expect us to use their hardware. You know, I've got a laptop sat next to me now from a customer that they give it, but generally they want you to be able to remote access into things. That's a tricky one. Yes, we do work on security cleared projects, but generally when we do that, we use some different systems, which I'm not for security reasons. I'm not going to mention too much about at the moment. But yeah, we do some defense work as well to do that. And the defense work can be quite interesting as well, you know, because it can be quite long term. So you can experience it. And that's one thing you need to work out when you're negotiating contracts and things. It's like sometimes you might want to give a slightly lower rate and accept for a longer term commitment than a sort of, you know, whereas short term stuff comes with a price. So I would say like price with evidence, not hope. And I'm going to talk about this in a second. But obviously, a lot of customers, a lot of clients want a firm fixed price. So the risk sits on you then if it's going to work or not. And the reason they tend to want firm fixed price from us is because we don't engage with them on a contract model where we're like it's like £50 an hour or something like that. You know, we want that fixed firm price. So what we do is we track hours that we're working on. So we track the hours that we're spending on things. Sometimes we get it right, sometimes we get it wrong. Sometimes we're like, whoa, that was really simple, and we thought it was going to take a lot longer than that. So we build a historical sort of data. We built like a historical sort of data set around that. And then I'll show you on the next slide. But we have an estimation for doing FPGA design. We have an estimation spreadsheet that we put the data in. That we put the historical data into it. And then when we use that to bid for new projects, so we put in data. We put in data on there. It's not necessarily due to IR35 reasons because we don't have. We fall outside the rules of IR35, right? We use our own equipment. We've got our own officers. We've got staff. We've got things like that. So we don't fall in it. It generally comes down to the fact that if somebody's going to give you a contract for maybe several hundred thousands of pounds. Then they want to know that it's a fixed sort of price, and that it's not likely to turn out to be a lot more than that. So it allows them to do their budgets, and that's how businesses work, right? Most businesses work on a fixed price. Most professional businesses work on like a fixed price relationship with each other. So yeah, we share our internal Duvo library with customers. So when we deliver the code, they get the library elements that they've used, and they get a license to use it. In that, we don't charge them anything extra for that. So we don't hide it away from people. If you get slowdowns in projects, well, that's important to handle those slowdowns in projects because it will happen. You know, requirements might change, things might move. We've got one space project. I started when my son was 2 months old. He's now 8, and we're still working on it. And you know, maybe it'll launch next year. And that's had some serious slowdown. You know, COVID had a big impact on it and slowing it down, but things like that. If people change requirements, generally we're a little bit flexible with that. So if it's a minor change, we'll accommodate it. but we might take a note of it in like the goodwill, in a goodwill register, and say, well, we did this, you know, we didn't come back and charge you. If it's a major change, you know, then we will go back and we'll talk to them again about the fact that, you know, this has been a major change to the requirements, and we need to we need to make some changes. We need to make some changes to it. But by and large, generally people are respective of this. People do expect this. If they change requirements, they do expect you to go back and, you know, if they change things, they do expect you to go back and change things. In fact, I had a customer the other day, they changed something quite significantly, and I'm like, and they're like, what's the impact on you? And I'm like, well, you know, it's actually not that bad. It's not too bad. It's like, so we can actually keep the price that we've originally quoted, and they were quite happy. They were quite happy. But you've got to do that assessment. So most of our clients actually are probably international. I would say maybe 60%, maybe a little bit more of my business is working with US customers, and then the rest of it is in sort of like UK, Europe, and the rest of the world. So we take all these, we put all this data and we put this into our estimation spreadsheet. And into our estimation spreadsheet, you know, we say what the FPGA is, we say what the block name we think it is, we say what the complexity is, we say whether we think it's coming from an IP code that we've got or not, and then we work out, you know, we have a standard. When you select either it's complex, it's simple, or standard, you know, you'll get a standard sort of drop through from our historical data dropping through in there. And that then shows that we can then tailor that to our heart's content, such that we can actually work out what the price is, and we can go through then and give a summary price for something. I will say the numbers in this, these are just numbers I put in there. They're not actually they don't actually equate to our hourly rates or anything like that. They're just numbers that I've put out there for demonstration purposes. But that allows us to be able to go to the customer and say, look, this is the logic. This is the logic behind the bid. This is the pricing behind it is. And, you know, if you've got anything you want to change, then we can do that. So someone who's asking, do I attend conferences? Yeah, I attend a lot of conferences. I attend like things like FPGA World, FPGA Congress. You know, I was at DAC, I was at MAPLD this year. I was at an ESA. I've been to 2 ESA conferences this year, and I also started my own conference called FPGA Horizons, which we had in London just last week, and we had 300 FPGA engineers last week, the week before last, and we had 300 FPGA engineers come along to that. Oh, and I launched an FPGA journal as well. About how to design FPGAs, like the old Xilinx XL journal. So if you've not seen that, let me know, and I'll put a link to it in the comments below. It's all free, and that, like, because, you know, I like sharing FPGA world. We do support customers post design. So generally we will put some hours in at the end and say there's like 20 or 30 hours or something of post support at the end, and if it goes past that, then I'm glad you liked it, David. Then if it goes past that hours, then we'll discuss it. Obviously, if it's an issue we've caused or something we've got wrong, you know, then it's on us to fix it. And we don't eat into those hours. But if it's something that they need or their support or something that comes out of it, then it comes out of those hours as well. So we talked about the scheduling and things like that, but one of the other things I want to talk about is making sure that we know exactly what we're going to deliver. So it's really important to be very explicit upon what success looks like, because your success and their success might be slightly different. I had this recently with a very large multi-billion-dollar customer, where we delivered something previously and they'd not checked it, and they said it was cool. And then we moved on to the next stage of it, which was basically taking that design and putting it on something else. And they were like, this is not what we wanted. It's like, no, but you agreed back here that this is what it was, because, you know, so why would we do anything different? So you need to be explicit on deliverables and what acceptance criteria looks like. And particularly like integration boundaries can be quite an important thing. So wherever possible, we will try, whenever possible, to do as much work on a development board, because we know that board's good. We'll get FMC cards, HSIO cards, PBODs. We'll make our own cards, whatever we need, to be able to demonstrate that on an equivalent FPGA, on the dev board, the system works. Once we know that works, we've retired a lot of technical risk, and we can move it over and port it onto the client's board, where things might not be right because it's a new board, it's just come out of things, so things might not work. There might be some issues with DDR performance or something, or the interface might not be quite right, or the pinout might not be quite right, or something like that. So it gives us that ability to do that. So we often offer sort of like, we'll do this for you we'll do this for you on the dev board, we'll get this working, and then we'll integrate it onto your board after that point in time. One of the other things we do, which is very interesting, is we'll sell people buckets of hours. So I have like several customers that don't necessarily want us to design anything, they just want to talk to me if they get questions or if they get challenges. So we'll sell them like sort of 30 hours of design support or something, that they can draw down on as they're going through their product or their projects. It's kind of like a gift card, an Adam Taylor type gift card that they can spend and use on the as they go through their integration and their project. So obviously somebody mentioned this earlier on. Why did we sell hours and not create products? And it's a perfectly good question, because by projects there is a limited number of hours that you can sell. It's also an easier barrier to entry to create to sell hours than it is to do these. But it's limited by engineering hours. I can't really work more than like 16, 17 hours a day. My staff, I would never ask them to do more than their contractual, 8 hours a day. So there's a limit, right, to what can be done. So we started, like I say, a couple of years ago, we started looking at this, we started creating products. We've created some very successful development boards. So we have just one example here. We have a space development board here that's been exceptionally successful in the space arena. We've sold more of those than I ever thought we would do. We've created our own sort of small sort of SOM type tile things that integrate, that are quite popular to go in there. And we've created IP cores and training courses. So every day this week I've been teaching a VHDL training course, an FPGA training course, to make sure that we, to teach people how to do that, and we teach people how to do mission critical things and things like that. And I actually generally really enjoy doing the teaching and the training. But we've got a range of things that we sell, and we've got IP cores, boards, training, and tools. I'm not going to talk too much about the conference, because actually the conference is a completely different business. When I decided the idea that we'd set up an engineering conference, I didn't want it to risk the engineering business if anything went wrong. So I set up a new business to do the conference and the journal. And that one's been a very exceptional learning business, because if I'm brutally honest, people paid and people came and they did a lot of things. But if I'm brutally honest, that was a different business model to whatever I've done. And the first conference probably cost me a lot of money. It probably cost me several tens of thousands of pounds to put that conference on. There's a lot of things that we've learned in doing that for the conference that's coming up in the US and the conference that's coming up in the UK, because we want to keep the same standard, the same quality, the same buzz, the same excitement, and provide the same things. It's just been, another engineering thing, a learning lesson. And to be honest, the fact that the engineering business has done so well was what enabled us to sort of have the conference and finance the conference when things get tricky. So like I say, we've tried to choose areas where we think we've got a right to play, where we've got that expertise and that credibility. So for example, we do a lot in FPGA world, in boards and training and such like, in creating these. And the conference was kind of like, well, if anybody can create a conference and run a conference in the UK, surely I've kind of got some expertise and some credibility to be able to do that. So we did that. Somebody asked what percentage of project time is usually spent on verification. I think the answer is a lot more than you normally think. I would say we probably spend about 60% of the time on verification, probably a little bit more off the top of my head. Doing the systems engineering, writing the RTL is the relatively easy bit. Verifying that it works and that it works across all the conditions, is more challenging and becomes more challenging to do. So just to show, we have some products out there. We have our tiles, we have our IP cores and our dev boards. So most of my customers in the US are in the US, Canada, UK, Europe, Australia, New Zealand, the rest of the, like the Europe and Americas really is where we are. I wouldn't say timing issues are a huge issue in our source code, to be fair, or in our products. I would say the biggest issue becomes sort of functional, in the customer specified it one way, we're integrating with their systems, and there's some sort of functional issue in getting them up and running. I would say by and large, generally we're quite good at making sure that we meet timing, and that we deliver that, because that's something that we have that's under our control. Like we can work through that, and we can run through that and get that. Tools, we've talked a little bit about tools. They are really what enables us to be able to do that. So we spend a lot of money on tools. And somebody said this to me the other day, actually, when I was talking to them. They're like, it's like, I really admire how the fact that you just, if money needs spending, or if you need to get something, you just go and buy it. You don't sort of quibble or question. It's like you just go and get it. And that's really my approach to something. If we need something, we go and get it. So we have a lot of development machines. We invest a lot in tools and things like that. So we have like, we have we bought the exhaustive debugger to do that. We have JTAG stuff. We have test equipment, scopes, power supplies, logic analyzers, all those sort of things that that we need to do, and software as well. We spend a lot of money. Like I said, we spend a lot of money on software. But there's no single recipe. You have to pick what comes and work that through to the best. So let's go for questions. So yeah, we do take on projects that run high-speed design, where they're greater than sort of 400-500 megahertz, and helping people get these things as time enclosure. Then yes, people are quite interested in that. The starting years are actually quite good. I scaled slowly, shall we say. I was quite slow to scale. Despite the fact that I went and created my own business when my son was like, a couple of months old, and I left a really well-paying job to do it. I'm quite risk adverse. So, before I started the business in 2014, I got an office in 2021. So I worked from my home office for like 6 years and built up reserves, and then it was only really once I got the office that I started thinking about recruiting people and scaling to a limited sort of extent. I think the biggest challenge in all these things, actually, in creating a stable business, is getting customers and managing that cash flow, and being able to keep an eye on it. And yes, Carl, we will take on pure systems engineering and project management work if people want it. People rarely come and ask it, but one of the things I should have put up on the slides of business, we'll do whatever keeps the lights on within reason. If we think we've got the expertise to do it, and we consider it moral and ethical, then we will do it. So by and large, Chris, when it comes to EDA tools, by and large, we tend to use proprietary customer tools, because that's what the clients want. That's what the clients work. They expect to see you delivering a board design they expect to see you delivering a design that's used Vivado, for example, and not one of the open source flows. We do use some open source tools. We do use a lot of things like FuseSock. I think FuseSock is one of the best build things ever. It's fantastic for building FPGAs. I'm a big fan of the Teros HDL add-on editor and Wavedrum and things like that. So things like that are enabling. I think that are really good to do, and KiCad. I talk about the space project that we've been going on for 8 years. We designed 6 space grade PCBs for NASA, the highest grade NASA ESA space mission that's going. We designed all those in KiCad at the time, because actually we couldn't afford an Altium license. So that's what we did. Or KiCad, sorry, how you pronounce it. And then like we use a lot of MathWorks and Simulink, things like that. How did I find the time? I'm a very good engineer, and I love technology. I'm probably not the best husband, shall we say. Um, but no, I've always been sort of focused on this, and my wife didn't. My wife didn't work, so it gave me the time to be able to do it, um, and get the business going. But I generally do. I mean, I generally do. Like FPGA is my life, which is probably a bit sad. But I generally do spend sort of like 16, 17 hours a day working, and most Saturdays and Sundays as well. I spend the majority of the day sort of working and doing things. Um, probably because I don't know what to do if I sit and I can't really sit and watch TV or anything like that. It drives me. I get bored very quickly these days. Uh, but yeah, it's all been good fun. So we use sort of like, we use a lot. Like I said, we use a lot of tools to help us do this. We use Atlassian for our central repository for a lot of things because it scales and it helps us working. A lot of our systems engineering work we do in Enterprise Architect. So we can do requirements tracking in there and architectures in there, and we can do auto generation of our structural VHDL from there. Although these days we've kind of moved that over a little bit more to MATLAB and to Simulink to do that. But we try to use the right, try to leverage tools wherever we go from. We have a range of tools, just to kind of show the sort of the tool chains that we use. We've got HDL Designer. I don't know if anybody uses that, but a lot of defense clients do. So we've got HDL Designer, VS Code, Teros HDL, GitHub Bitbucket. We kind of use for source control. Model-based tools. We spend a lot of money every year with MATLAB and with Simulink. Our simulation is mostly done with Questa, but we do use some GHDL. For things like that, and Vivado Sim if we're doing sort of low stuff. And then for static analysis, we use the Blue Pearl Visual Verification Suite for static analysis and for checking of CDCs and things like that. And we find that's quite useful when we're doing sort of space type applications and so on. Following question: what's your favorite tool to describe your hardware description code for someone who has access to Model Sim Questa? So I tend to use VS Code for a lot. We tend to use VS Code for a lot of describing and capturing our code. Although these days I'm trying to do more in the model-based approach. Sagacity I've never really used a lot of, to be honest. I've looked at it in time, and it's been quite impressive from what I've seen. But I've never actually used it in anger in a development project, shall we say. When it comes to implementation, we've got all the standard tools you would expect: Vivado, Libre, Quartus, Radiant. We do Altium for most of it, although we've done KiCad for some of it. And as I mentioned earlier on, we try to have a perpetual licensing strategy. Altium just got me on this one, and if you follow me on LinkedIn, you'll see me complaining about what Altium have done there. But it means that if you have a bad year, you don't lose the capabilities of the tool chain that you've got. So it's all good. But every year we try to budget for what the maintenance is going to be, what the support's going to be, and it seems that I'm in this loop now where every month I have to pay for something, where I have to pay for like the Simulink licenses or the Vivado renewal or the Libre renewal or the I would say the Altium renewal, but they stopped selling me things. Yeah, so I did work from home for probably about the first sort of 5 years or so. I was working in an office in my at home, and then I moved into the office that you can see. Actually, I moved into the office next door, and then I moved into this office. What made me decide to hire engineers is I decided that I wanted to give back to engineering because engineering has been fantastic to me. And it was in 2021 when I moved into this office, and this office is linked with a university. And they got some graduates that were looking for jobs. So I'd always been a bit nervous about employing people, but then I then took on one of their graduates, who actually turned out to be one of the best graduates I've ever taken on, and that kind of broke me down. That kind of, I won't say broke me down, but made me feel comfortable about employing people. And then I went away and I've employed people ever since. I've employed some really good friends of mine. We've had some really great time, and people come and people leave. People stay for a couple of years and move on or whatever. But it's all good fun. Cleo, it's an interesting question about AI support and AI tools because we've just been looking at this. So I'll put it in the chat and I'll let everybody see what they think about it. So we've created, well, we're creating a little tool. Basically came from a discussion I had with somebody at the water cooler in the office building here. They're a small AI company, and we said, wouldn't it be cool if you could take your requirements, like your text, your plain text requirements, and you could take your VHDL or your VHDL, or actually C or Python or whatever, and actually train the AI to actually look at it and say, do you know what, this code actually does meet the requirements and demonstrate the requirements that have been placed upon it, or it doesn't, and for these reasons. And then we've been talking to the European Space Agency about it, and they've given us a little bit. For the first time ever, everything I've done so far has been like bootstrapped, and I've invested my own money. For the first time ever, the European Space Agency is giving us a little bit of money to go away and take that out take a look into that a little bit further as a grant. So if anybody's got any ideas or thoughts on that idea, I would love to hear them. It's not there to replace verification, but it's there to kind of like shine, like linting does and structural analysis does. It's kind of there to shine a spotlight on your RTL and say, actually, you think this does this, but actually I'm not sure, and here's why I'm not sure. So go take another look at it. Yes, sir. I'm one of those weird employees. Weird employees. I want my people to be happy. So I try to let people do whatever they want, to do within reason. Obviously we have to make money, and we have to deliver at the end of the day. But one of my engineers at the time, he came to me. He's like, dude, so I've been doing FPGA for so long. He's like, I want to design a board. I don't think I've got any about. He's like, I want to design a board. I'm like, cool. Let's go design a board. So he designed the little Spartan dev board that we have with the little Raspberry Pi Pico on it and the little small Xilinx FPGA. He designed that. He sat and designed that for KiCad. Actually, he sat at the back of a conference we went to and did most of the design work in KiCad. But he designed it, and then we invested it and built it. We don't see a lot of migration to ASICs, to be honest. Most of our customers come and they want to use FPGAs, not. Is there anything else I want to say? They want to use FPGAs, not ASICs, by and large. How can you and the team determine that the design will meet what's the PPA, the performance, power, and area, using HDL coder? I mean, to be honest, HLS we use a little bit. I would say HDL coder we use a lot more. And if you do it right using HDL coder, it looks human readable, and it actually synthesizes into pretty efficient code. We've done some sort of space imaging FPGAs for customers where we've never really touched a line of RTL. We've used our IP library. We've used our enterprise architect tool that generates the architecture, and then we've used model-based engineering to actually create the functional blocks in there, and we've done that on sort of like three or four projects now. So when it comes to like sort of IT, obviously we give VPN access, and we have CI/CD things. We have sort of remote. We have obviously everybody gets high performance laptops. I'm just in the process of changing mine from my old laptop to this new laptop that I'm talking on now, and I'm pretty sure it's easier to change to like emigrate and such like that than it is to change laptops, because it becomes so painful to get it set up again. And we've grown gradually. I would say that over time we've grown gradually, and we've tried to take our time and be very sensible about how we've done it, and take it out there. That's pretty much everything I've got to say. I'm amazed it took me an hour to get through. Actually, I figured it might be a lot quicker than that. Martin, I think eFPGAs are going to be quite interesting. I think they're going to provide some flexibility. Demand for FPGA jobs. Obviously I'm in the UK. Demand for FPGA jobs is off the charts. It's people just can't get FPGA skills. And that's really, I think that's really important. Somebody was asking some questions. It's all flying by. So yeah, I'd consider joining an advisory board because it could be quite interesting and quite fun. And we've got there Versal. I think is very interesting. I think Versal's we're beginning to see a lot more people talking about Versal. So we're seeing a lot more customers. We see a lot more customers wanting to use Versal. I will admit, most of our customers that wanted to use Versal have wanted to use it for things like beamforming and things like that, not particularly AI inference. But we're seeing more people use Versal, particularly as the edge devices come out, so they're cheaper and they're more accessible. But I think they're very good. I'm a big fan of Versal. Thanks for sharing your knowledge, by the way. Yeah, FPGA pay in the UK is terrible. You know, you might see some comments I've made on LinkedIn today at a large company about the salary they want and the role they expect for that sort of person. What have we got there? Thanks for that. I think, to be honest, if you looked at the chart back at the beginning, the smart ones of you will have noticed that there was a small overlap between me working and me starting my company. So I did both for several years, for a good couple of years, to build up some reserves and to actually work out that it was viable to do it. It just got to a point where I needed to make a decision. Did I want to be an executive, or did I want to did I want to do the stuff that really made my heart sing? And I decided that why not? I'd give it a try. And I don't think so far it's gone too bad. You know, you never know where things are going. You never know where things are going to go, what things are going to turn out. You know, so I'm just grateful every day that I get to do this and play with FPGAs and things. But it's been good fun. So what other questions do we have in there? So somebody asked a question. So I mean, the main thing for FPGA, apart from dev boards, if you need to push any, the main thing, like maybe a JTAG debugger, like a SmartLink or something like that, is quite useful. A lot of people don't understand what the work involves. No, I can see the point about the ecosystem and trying to get an ecosystem up and going. You may see some things about that. One thing I'd actually like to do is, and this is just me like my vision, I'd actually like to set up some sort of scholarship to get people to do engineering, particularly FPGA engineering in general, because I came into engineering in a bit of a weird way, but I'd like to do something like that. Okay, I think that's it. Any other questions? Feel free to throw them in the chat. This has all been recorded, so you can come back and watch it again. If you can't sleep, it'll help you sleep. I'll pop it on my LinkedIn channel. As well. And we have, like, if you're looking for FPGA stuff, we have a conference coming up in the US in April next year, and we have a journal on there that's going to run quarterly about FPGA. So if you want to write about FPGA, like the old Xilinx XL journal, then go read the journal, contribute an article. You know, we all go further when we work together. Adam, a MIPI analyzer that's affordable. I'm afraid I can't. I'm afraid I can't on that one. MIPI's one of those things. It's like when it works, it works. When it doesn't, it makes you want to pull your hair out, I'm afraid. No, the exhaustive doesn't cover CSI2. The exhaustive is really cool though. I mean, if you're doing an image processing chain, you can connect in the exhaustive to parts of the image processing chain and pretty much stream out the image at that particular point in it and run out with it. And I can't suggest an SI analyzer compatible with KiCad because I don't actually do much SI. That's one of the things that, I mean, we use hyperlinks, but that's one of the things I pass over to a friend of mine, Dan Binnen, who's an excellent engineer at E3 Designers, and I wrote the book that we wrote on designing an embedded system. I wrote with Dan. I would, Miguel, that's an interesting one. You know, I covered that early on. I would probably say it's projects, not years, but I would say probably somewhere between 5 to 10 years of projects. I've seen a good range of projects before you before you think about sort of going on your own, because it's not just doing the technical bit of it that's the important thing. It's how to do it when it's what to do when it goes wrong, or it's what to do when somebody tries to, you know, manipulate you or get something out of it or something like that, or change the goalposts. You know, you need that business level understanding as well, of that, and you need to not be scared of people shouting at you as well, because people generally don't. But you know, you need to be quite capable of giving good news and bad news, and you need to also know how to manage people that work for you in their careers, because it's their life, right? So you need to be able to make sure that they get the training they want, the skills they want, the engineering work they want. And if they're not performing as you want, you know, you've got to be able to have the conversation with them and say whether they're performing or not. And in some cases, unfortunately, you have to say, you know, this is not working for us. And you have to, you know, you have to go and, you know, unfortunately, the relationship ends. No, you can't, Adam. It's a great question. That it's it's a challenge, and that's why one of the things that I like is to try and structure the payment such that there's not actually that much left at the end, because you can't anticipate it, and probably you can't legislate. You don't want to go to court and take them to court over it neither, because that just becomes a time sink and it costs you money and things like that. So sometimes you just have to sort of know when to cut your losses. Is another thing. You know, I said we had one project that was like a 6-month project for ESA and NASA, and then it turned into a like a 3 or 4 year project that kept starting. In the end, we told the customer to take it away. We were like, this is not viable for us, because so we've designed the board, we've got you some basic FPGA code working on it, but this is as far as you can take it, and you know, here you go, you take it back, because this stop start model, it doesn't work for us. So that's the other thing. Don't be scared to fire customers. You know, you'll get good customers that you should keep. Bad customers, you know, feel free to kick them to the curb, as they say, and say, we're not going to be doing any more work with you, because you know life's too short to do that. I can see a couple of other people typing, and then I'll end it. But honestly, thank you very much. I hope you've all enjoyed this. By the way, I feel like I've just turned up and rambled for an hour about what I've done as an engineer. So hopefully you've all learned something, and it'll be available. Right, I'll say goodbye, and I'm going to go and play with some FPGA code. And Carl, I hope that book works. We did actually design the board. I don't know if there's a picture of it in the book, but the board is here that book talks about. So it's and it does work. It was a prerequisite for publishing the book, was that we had to design the board and manufacture it and test it. Otherwise, the publisher couldn't publish it. Because I didn't want to be one of those people that writes about things but can't do it. Right, on that note, I will leave you all in peace, and thank you very much. And I will speak to you all again soon. Thank you very much. Bye-bye.